Hey everyone, check this out. Scientists just found a supermassive black hole, a whopping 5 billion light-years away from Earth. This thing is insane. It's got a mass equivalent to 36 billion suns. Yeah, you heard that right. 36 billion. It's sitting right at the heart of a super distant galaxy nicknamed the Cosmic Horseshoe, and that galaxy is absolutely enormous. On August 7, 2025, a paper got published in the monthly notices of the Royal Astronomical Society all about this black hole, and get this, it is almost 10,000 times more massive than the black hole at the center of our own Milky Way. Just let that sink in. The whole galaxy must be unbelievably huge. But here's where it gets wild. The more scientists looked into it, the more they realized this isn't just any black hole. It's hiding secrets that could totally change how we understand the universe. The image you are seeing right now is one of the most famous examples of gravitational lensing ever. And just a few months ago, researchers officially announced the discovery of this supermassive black hole with 36 billion solar masses. The whole science community was shook, because that's practically at the theoretical limit of how big a black hole can even get. Most supermassive black holes act like the heart of a galaxy. Take Sagittarius, a star in our Milky Way. It's got around 4 million solar masses, and it literally makes every star in the galaxy orbit around it. Now, in theory, there's no upper limit to how big a black hole can be. But in reality, the age of the universe puts a cap on it. I mean, the universe is only about 13.8 billion years old, and black holes can only grow so fast. So there's only so big they can get. How does that work? Well, there's this cool physics behind it. When a black hole feeds, it gets crazy bright and releases insane amounts of energy from its accretion disk. It's basically eating stars and shining ridiculously bright at the same time. So bright, in fact, that the pressure from all those photons actually pushes surrounding material away. That's what scientists call the Eddington limit. Once the radiation pressure gets stronger than gravity, the black hole can't pull in more material to grow. So if a small black hole started growing right from the beginning of the universe, the biggest it could possibly get by now is around 15 billion solar masses. But this one, it's 36 billion. So how the heck did it break the rules? Turns out it's got a lot to do with Einstein's theory of general relativity. According to that, supermassive objects warp spacetime. Imagine pressing a heavy ball onto a stretched rubber sheet. It creates a dip. When light passes near that warped space, it bends. That's gravitational lensing. In the case of the Cosmic Horseshoe, there's this huge galaxy in the foreground acting like a natural magnifying glass. It bent the light from a background galaxy into this horseshoe shape, and right at the center of that background galaxy is where this supermassive black hole is hiding. Here's another twist. This black hole is currently dormant. It's not active, not feeding, not shooting out energy. So how did scientists even find it and measure its mass? They used two brilliant methods. First, gravitational lensing. By measuring how much the light is bent, they could estimate the strength of the galaxy's gravitational field. And since gravity relates to mass, they could make an educated guess about the central black hole. But that method isn't super precise. It only gives a rough idea. So they brought in the second technique, stellar dynamics. By studying the speed and motion of stars near the galactic center, they could calculate the black hole's mass more accurately. Stars move under the influence of the black hole's gravity, just like planets orbiting the sun. Track the stars, and you can work backwards to find the black hole's mass. Using images from the Hubble Space Telescope and data from the Multi-Unit Spectroscopic Explorer in Chile's Atacama Desert, researchers ran complex calculations and confirmed the black hole's mass, 36 billion solar masses. And this result is super reliable. It hit the 5 sigma detection threshold in scientific terms. Now, before this, there were other claims about huge black holes, like the famous Ton 618 and Phoenix A. Ton 618 was first thought to be 66 billion solar masses, but later measurements brought it down to maybe 4 billion or even less. But this one, the Cosmic Horseshoe black hole, used way more advanced methods, so it's a lot more trustworthy. Another cool thing, this black hole's galaxy is special too. It's what we call a fossil galaxy. Basically, it formed over billions of years by merging with tons of smaller galaxies. Way back when, there were probably over a dozen galaxies in this region, and they all merged into one giant galaxy. And during that process, all their central black holes merged too, creating the monster we see today. That gives us a huge clue about how some black holes grew so big so fast, even though the universe might not be old enough. Astrophysicist Thomas Collett thinks what we're seeing might be the end stage of galaxy formation, where most black holes in galaxy clusters end up after evolving together. Scientists also found that, when two supermassive black holes merge, they kick out a ton of stars from the system, turning them into cosmic rogues. So the total number of stars in the galaxy drops, but the black hole's mass stays the same. That means the black hole makes up a bigger share of the galaxy's total mass. Plus, during their active phases, black holes like these produce strong feedback that can actually shut down star formation. In this study, the combination of gravitational lensing and stellar dynamics gave us a super accurate mass measurement, and it's pointing the way for future astronomy. We can use methods like this to study more targets and unlock more mysteries about supermassive black holes, like Phoenix A and the puzzling Ton 618. But we still haven't figured out why some ultramassive black holes are so much heavier than theory says they should be. So far, we know of at least 3 black holes bigger than 50 billion solar masses. And that's leaving scientists scratching their heads. Maybe for a long time to come, these 3 ultra-giant black holes will remain some of the universe's biggest unsolved mysteries, just waiting for us to figure them out. Make sure to hit that subscribe button, give this video a thumbs up, and share it with your friends and family. Thanks a bunch.